Okay, so you should be on page 49 in your journal. You need to set it up like it is set up on the screen. Your title is Series versus Parallel Circuits. When we are talking about series circuits, you're going to fill in the blanks on the series side. When we are talking about parallel circuits, you're going to fill in the blank on the parallel side. And then we will come back and we will look at those diagrams at the bottom, at the end, and learn how to effectively read a circuit diagram this year in 5th grade science. Remember, if for some reason you can't find the handout that I gave you, you are a super awesome problem solver. Okay, so let's look at the difference between series and parallel circuits. The first one we're going to look at is a series circuit. It's the most simple one. There is only one pathway to and from the energy source. So here is an example. We're going to start at the positive end, and we're going to travel to light bulb 1, and then we travel to light bulb 2, and then we come back to the negative end. And you can see there's just one loop around. Okay, and that's the important thing in a series circuit. It's basically like a big circle. Everything's connected on one pathway to and from the battery source or the energy source, whatever the energy source may be. Also, in a series circuit, the second important thing to remember is that if one light bulb goes out, they're all going to go out because they're on the same path to and from the energy source. So here you can see we are starting at the positive end, and we travel to light bulb 1. Well, if light bulb 1 is not on, we travel to light bulb 2, and here you can see there's a break. So remember, we learned how if there's a break, then it's an incomplete pathway, so it's an open circuit, so the energy is not going to work. And since this is on the pathway for both light bulbs, then it's going to cut off the energy to both of them, so both light bulbs will go out. In a series circuit, that's the important thing to remember. And then we have a parallel circuit. So you can see it looks a little more complicated than our series. You can see there's actually two loops here. Okay, there's more than one pathway to and from the energy source. So each light bulb can be on a completely separate path than another light bulb. Okay, so here we have the first one right here. Here's your positive end. I go to light bulb 1, and then I go back to the negative end. So you can see this is one loop, and I haven't even touched the second light bulb yet. Okay, but then if I go here, you can see there's a separate pathway for the second light bulb. So in a parallel circuit, you'll notice, look right here, the break is on the second pathway. So even though that wire is cut, it's not affecting the pathway of light bulb 1, because here you can see it goes from the positive end to the negative end, and that light bulb is still on. So the important thing about a parallel, and the reason why it's different from a series, is that if one light goes out, the rest will stay lit, as long as they have a complete pathway still to the battery. Okay, so this is when tracing the pathway is going to become so important, and that's a big strategy that we're going to use this year, is tracing the pathway for each light bulb or each object it's turning on from the positive end to the object back to the negative end, and seeing if it is a complete path. Okay, so let's look at some examples. So we have the one on the left, and then we have the one on the right. Which one do you think is a series? Which one do you think is parallel? Make your guess, and then after you have made your guess, press pause and then play, and you will see the answer, which is this. So the one on the left is a series because you can see both light bulbs are on the same pathway. In parallel, the one on the right would be parallel because you can see there are two separate pathways. Okay, there's two loops basically. Okay, so we're going to go back to our notes page now and look at how we need to trace the pathways on a circuit to be successful this year. Okay, so now that we know the difference between a series and a parallel circuit, let's put it into practice. So you should be on page 49, and at the bottom of our page we have some diagrams. And let's look at how we should approach a question that involves a circuit. Okay, so we are going to need to do some tracing so that we can make sure we figure out which light bulbs are turning on and which light bulbs are turning off. Okay, so we're always going to start at the energy source. Okay, we're going to start at the positive end. We're going to travel here. We see that the switch is closed, so we know that the switch is on, so that means the energy is going to keep going. It hits light bulb 1, it hit light bulb 2, and then it goes back to the negative end. Okay, so you can see everything here is connected. It is a complete pathway, so that means both light bulbs will be on. Now, look what happens here. Okay, this is, remember, a series circuit. Okay, and in a series circuit, they're both on the same pathway, just as you saw right here. Here, same picture, same circuit, but they took this light bulb out right here. So if we, again, started our energy source, we see the switch is still on, so the energy is going to keep going, but look what happened here. They took the light bulb out, okay? When one light bulb goes out in a series circuit, the other light bulb is also going to go out because they are on the same pathway. So if I cut off the energy here, then that means I also cut off the energy right here. Okay, that's because it is on the same pathway. Okay, but now let's come over here to our series circuit. Oops, I'm sorry about that. Let's come over here to our series circuit. You can see it, or our parallel circuit. It is a little more complicated. Okay, so here again, I'm going to start with my battery, my energy source. I'm going to go, we're going to call this light bulb 1, light bulb 2, and light bulb 3. Okay, my switch again is on, so I should always label that. I'm going to go just to light bulb 1. Okay, I go one end, I come around, and then I go back. Is everything connected? Yes. So if everything is connected, then light bulb 1 will be on. But notice the pathway. Okay, it is completely different. I haven't even hit light bulb 2 or light bulb 3, have I? One is on its own path. Okay, but now let's focus on light bulb 2. So again, I'm going to start right here. I'm going to go to light bulb 2. I'm going to come back around, and you'll notice, again, a complete path. Everything is connected. Okay, so it is on its own pathway. Now let's look at light bulb 3. Okay, and here we go. Again, own separate pathway. Okay, so it's the thing you have to remember about a parallel circuit is that all three of these light bulbs are on their own pathway. Okay, in a series circuit, remember there was just one path, and each light bulb was at a different part of that path. But here you can clearly see that each light bulb has its own pathway to and from the battery. Okay, so let's look what happens when I remove the energy from light bulb 1. Okay, so when I remove the energy from light bulb 1, I start again right here. I travel to light bulb 1. I notice there's no light bulb here, so there's no energy. Okay, everything is connected. However, they took out the light bulb, so it's not going to work. But notice, is that affecting light bulb 2 or light bulb 3? No, because they're not on light bulb 1's pathway. They have their own pathway to the energy source. So even though 1 went out, 2 and 3 are still on, because look at this. Here again, I go from my positive end. I hit light bulb 2. I come around back to the battery source. Is it a complete pathway from the energy source to light bulb 2 back to the energy source? Absolutely. My switch is on. The wires are connected in the right place. And as you can see, it is a complete pathway. So the fact that this one went out is not going to affect this one right here as long as there is a complete path to and from the energy source and the destination for the energy. Same thing here with light bulb 3. So right here, again, I start with my energy source. I hit light bulb 3. Everything is connected in the proper place. So light bulb 3 is still going to stay on. Okay? So I want you to study the difference between series and parallel. And tomorrow we're going to practice tracing circuits and identifying whether a circuit would be series or whether a circuit would be parallel. Okay, so make sure you start studying the difference between the two, and I will see you tomorrow.